This leads us into what the definition of what the definite integral is. The definite integral is the area under that curve or under that function on a specific interval starting point A, ending point B. So that formula that we just saw, the area of the rectangles, and you see that by the width of the rectangle times the height of the rectangles and adding up those sums, and as the limit as the width of those rectangles approaches 0 but not equal to 0, that's equivalent to the definite integral. Now, just like I was saying, a geometric representation of a definite integral would be like, let's say I have this function and I want to find the area under that curve from starting point A to starting point B. The way I could find that area without having to do approximations with rectangles would be to take the definite integral from A to B of that function, and that's the definite integral. Now, here's the thing about definite integrals. As long as the function is continuous on that interval, then therefore it has to be integrable over that interval. So obviously, if the limit exists, then it's continuous and it's also integrable on that interval AB. All right, one other thing is that whenever you are talking about the area, any area that is above the x-axis is going to be a positive value. Any area that's below the x-axis, that's going to be a negative value. Now, there are some rules for definite integrals. They're right here, these 5. First of all, whenever you have the integral, definite integral of a constant, that's equivalent to that constant times the difference above the starting point and the ending point. If you have a constant times a function, you can pull that constant out and it's equivalent. If you have a sum, you can split it apart and do one function plus the other function. Whenever you reverse the limits, like let's say that you want to take the definite integral from B to A and then you want to go from A to B, the difference is that the reversed definite integral would just simply be the opposite of whatever the original integral was. And finally, if you have an interval from A to C, and then there's some number B in between there, if you want to find the area from A to C and B's in between there, what you could do is you could find the area from A to B and then find the area from B to C and then add those two areas together and get the area under the whole curve. So those are 5 rules that you need to make sure that you know.